So, hello there, guys. Our class at Immaculata, SNC2D, have been working over the past few weeks to prove that anthropogenic, which means man-made, carbon dioxide exists. First thing we need to know about is combustion. Combustion is the burning of a fuel, and we get these fuels from fossils in the ground, and we burn them. And I'm going to prove to you that this makes carbon dioxide. So I have lime water, which is calcium hydroxide and water, and it should turn cloudy. It's clear right now. It should turn cloudy when it's exposed to carbon dioxide. So I'm going to pour some in my test tube. Here for now. Light a splint. All right. It should put itself out here. Yeah. I'm going to close it and shake it. And yeah, it did turn cloudy, so that's proof of carbon dioxide. And I'm going to pass it over to Logan Captain.
All right, so my name is Logan, and my experiment, what I decided to prove is that CO2 is a greenhouse gas. Yeah, there we go. So a greenhouse gas is any gas that retains heat and then re-emits it. Greenhouse gases are naturally found in our atmospheres, and they're really important for us because if we didn't have greenhouse gases, all the energy we get from the sun would just come to Earth and then just go right back out. And our global temperature would be negative 18 degrees Celsius if it wasn't for greenhouse gases. So they're important, but if there's too much or too little, then it's catastrophic. So what I wanted to prove here is that CO2 is a greenhouse gas. So how I did that is I have two Erlenmeyer flasks here. This one is just regular air, and this one here is a carbon dioxide. And here I have a heat lamp, which is representing the sun. So if we look at the one that's just regular air, you can see that it is 52 degrees Celsius. But if you look at the one that is carbon dioxide, you can see that it is 80 degrees Celsius, which means that inside of the Erlenmeyer flask with carbon dioxide, the temperature is 30 degrees higher, which proves that, you need to point that a little bit, yeah, which proves that carbon dioxide is a greenhouse gas. Next, I'm going to hand it off to Alex.
Hi, I'm going to be proving to you today that we have learned different things about carbon dioxide, how it's produced, and that it's a greenhouse gas. I'm going to be teaching you that carbon dioxide dissolved in water produces acid. So this is phenolphthalein is an indicator. When something is basic, it turns pink, and when something is acidic or neutral, it turns clear. So I'm going to put a couple drops of phenolphthalein in here. And this is a sodium hydroxide. It is a base, and you know it's base because it has hydroxide at the end. Hydroxide is oxygen and hydrogen. And I'm going to put a couple drops of sodium hydroxide in here, and it should turn pink. You can see it's turning pink right there. Now, you are a natural combustion engine, and you do this by breathing out. When you breathe out, you produce carbon dioxide. And so I'm going to blow into the solution, and it should turn clear. And while it did take a bit of time, you can see that it is now clear and no longer pink. And that's proof that carbon dioxide dissolved in water produces acid. Now I'm going to hand it off to Fatima, who's going to see the effects of acidic water.
So because the ocean is becoming more acidic, this actually affects what's living inside of the ocean. So anything made of calcium carbonate, those coral or the outside of a shrimp can actually start to dissolve. So here I have pop, orange juice, and vinegar, and I left these in overnight. And eggs are also made of calcium carbonate, so this will work as well. So I'm just going to show you the vinegar because it works the best. So as you can see, like I can squish it, and it's not hard anymore. And if I break it, it's actually hard.
Oops.
And here's the egg. So if this is what's happening to the egg, then just imagine what's happening to the animals inside the ocean. Now this isn't the only thing that's happening inside the ocean. So I'm going to hand it off to Alex again.
Here's another experiment relating to the ocean. We have two things here, and I'm going to prove that icebergs, when they melt, they don't rise sea levels, but when glaciers melt, it does rise sea levels. So you see, if you could zoom up on both of these, we put water in both these, and we drew a marker for where the water was at the beginning. And on this little clay bed, which is insane, but we put an ice cube on top of that, and we put an ice cube on top of this. So as the ice cube melted in this one, it ran off into the water, and its runoff into the water rose sea levels from the runoff. And the iceberg, which was already in the water, kept the water at the exact same level. And this is causing a lot of cold water to go into the oceans. If you think of Greenland, there's a lot of runoff of that, and that will have consequences that you see later on. You also see what's causing the melting of the glaciers.
Okay, so the albedo effect is also causing glaciers to melt. So I'm trying to prove that surfaces like the black clay, which is like water, absorbs heat, and surfaces like the white clay, the heat is reflected. So as you can see, the black clay temperature is higher, and it's at like 46. And for the white clay, the temperature is at like 32 because the sun is being reflected. So in our planet, the ocean is like the black clay, and it absorbs heat. And the heat melts the ice, and ice melts and makes more water, and more water takes in more heat, which melts more ice, and that just circulates, and it's called a positive feedback loop. So this is not the only thing that's happening in our oceans. Warm fresh water is also affecting something called thermohaline circulation, which is what the next group is going to
So, as Chris mentioned, the icebergs and ice sheets in the Arctic, if they start to melt, more fresh water will be released into the ocean, and this could possibly affect the ocean conveyor belt and the currents, and we're here to prove thermohaline currents.
So the ocean conveyor belt and thermohaline circulation is pretty much warm and cold water being circulated around the planet. So you'll take the warm water from the equator, it'll go up towards the poles, get cold, and circulate back down towards the equator, where it will become warm again. So here we have some warm fresh water, and that red, that is warm.
And here we have some cold, salty water, dyed blue to indicate it's cold. And what should happen is it should be sinking to the bottom, like it does in the ocean, and the fresh water, the red, should be
So as you can see, the red warm water has moved itself to the top, and the cold blue water has sunk to the bottom, and that's because which is we put salt in the blue water to make it more dense. Represent so what this could do our best is if there's more of the red water, which was the fresh water, it could shut off this circulation, which could lead to another ice age because the warm and cold are not being circulated around the planet. And yeah, it just changed the climate all around the Earth, which would be bad. And next up,
Here, that by us burning fossil fuels, we produce CO2. It's also proved that CO2 is a greenhouse gas. Now, when the ocean absorbs the CO2, we proved that when it does, the water actually turns into acid. And this acid, as we proved, dissolves shells. Also, by proving CO2 is a greenhouse gas, that it heats up the Earth, and when it does, it causes ice to melt, more specifically the glaciers. It proves when glaciers melt, the sea levels start to rise, and it covers the land that is previously on. By covering this land, the Earth starts to heat up, and because the land is darker than ice, the albedo effect, it then starts more ice starts to melt. This positive feedback loop causes more fresh water to be put into the ocean. As we increase the fermentation, more salt water moves and more fresh water rises. By adding more fresh water, this throws the circulation out of balance and stops the cycle. So as you can see, everything that we put today is connected, and that CO2 emissions are responsible for this, and it affects us and our climate. And I'll have it.
Okay, so I don't know about you guys, but all the things that we proved today, it's kind of scary. What all this together proves is that in the future, it won't be the same as it is right now, and it could have catastrophic impacts on the way we live our life. So at Immaculata here, we've created a club called the Eco Club, and one of our projects is called the Carbon Sink Project. Now, a carbon sink in science is anything that pulls carbon dioxide from the atmosphere, so trees, plants, oceans, etc. However, we've built these sinks. There's old sinks, as you can see, and we've put plants in them. So these are actually sinks that pull carbon from the atmosphere. So it's a little bit of a fun. We have 9 of them in total, and all of our students have come in their own time to create these sinks, and we'll be selling them to different sponsors. On Wednesday, May 23rd, you're all invited to come check out all of the carbon sinks that have been made. This is only one of them. You can check out all of the carbon sinks that have been made, and also watch some more awesome experiments and whatnot. If anybody feels inclined, they can build their own carbon sink. We have one left over. If you really want to help support the environment, then you could come and build a carbon sink for next Wednesday. Something else. That's it. Sorry. Oh yeah. Anybody have any questions? Will. So anybody have any questions for anybody?
Please type in your questions if you have any questions.
No. No questions? Oh, the phone's ringing.
Phone's ringing.
N407.
Thank you.
Our room number is N407 if you need to call.
Okay.
It's filming.
They're wondering how do they ask questions? They're like wondering how they can send in questions.
Oh, you can everybody in the school. Why don't you call us, because the sound doesn't seem to be working on this broadcast. So call us. Our classroom is N407. Yeah. Yeah.
Oh, there it is.
Is this true? Yeah, it is. How many people are in there? Wait, how many people?
Oh, there it is.
There we go.
We can also hear you guys if you just say your questions. We can hear you.
Hi.
Whoa.
Hello.
No, your mics. Oh, your mics are all turned off. Hopefully, I just erased somebody.
Everybody's mic. I don't know how to undo that.
Please log back in.
The rate of the ice caps are melting.
Anybody on that? That was me.
I'm not sure.
Okay. Miss Sweeney asked you guys a question too. English class asks, what can we do as a class to prevent climate change? You want to take that out?
So there's a lot of ways that you can prevent climate change, and the most important one is to reduce your greenhouse gas emissions. We do a lot of stuff in our life that all our energy, the lights in our schools, the cars we drive, they're all carbon emitters through just the way we get energy. And if you could bike to school, if you could take public transit, if you could turn off the lights when you're not using them, that's all helpful in reducing our greenhouse gas emissions. Do we know who made this sink?
Yeah.
Yeah. Oh,
Yeah.
What do the clouds symbolize?
Well, for us, we're mostly focusing on the greenhouse gases, and so that's how you do the clouds of the sky. So even though you can't see them, they're still up there and they're still affecting us.
What was the hardest challenge for this task? That's by Chloe. What was the hardest part that you guys found?
We'll answer that one.
I think figuring out how to do the experiment in a way that people can see it.
The visual.
Yeah.
We have a question from another class. What are we raising money for? We're raising money for a couple different things, and the most important thing is we're going to try and send a girl to school in a developed country or in Africa. One of the most important ways we can reduce climate change, which I failed to mention before, was educate girls, which is mostly because we read this book, and educated girls are more worldwide. Girls are less likely to be educated in developed countries, and when they're educated, they become more productive. They become more productive in being in science, and they also have less children, which reduces population. Hello. Okay. Okay. Here's a question for Brendan. What does global warming have to do with hurricanes? Yeah.
What does global warming have to do with hurricanes? Because the more the atmosphere and the climate changes, the more unpredictable the weather, like hurricanes, would be. Correct? They did. I believe.
I mean, it's adding.
Yes, yeah.
And the temperature is rising, which the difference in temperature affects the hurricanes.
We have another question from Miss Sweeney's class. How long have we been working on this? Throughout the year, whenever we were learning different stuff about chemistry and climate, Mr. Blaine would write different things that we would prove it on the boards. We've been working on it almost all year long. We started on the individual experiments about 2 weeks ago-ish. Yeah. Oh, here's a question coming in. What plants are best to plant in a carbon sink or a sink? Does anyone know the answer to that? What plants are best? Vegetables. Vegetables. Big are the best to,
Vegetables are the best to plant because not only do they attract carbon, but they also provide food and just for you. Your mouth.
I think that's it for now. Thank you for watching. As Logan said, there's the carbon sink showcase on the 23rd next week. So hope to see you there. Thank you.